Yeah, hi friends. Good morning, everybody. Today I'm discussing about NLTK functions of the natural language processing. In this PPT, I will discuss about what is NLTK and with the NLTK what we can do, and we have do multiple things in the natural language processing with NLTK. So we will discuss further what is all about. Okay. First of all, what is NLP? NLP is a natural language processing. It converts our human language into the machine language so that it more helpful in the AI, machine learning, linguistics. Because in the if you could see the linguistics or any AI, the user used to give the input in a human understandable language. So it should convert into the machine language so that machine understand what we are saying. So there in the name itself, language processing, so it will process the language into the human language, to the machine language. So it helps in creating in the backends of the chatbots, backends of the translation, backends of the sentiment analysis, because the chatbots translation, so we as humans giving some typing some inputs, so it converts the inputs exactly what kind of output we want. So where we use this natural language processing more extensively. It comes to next slide. What is NLTK? NLTK is natural language toolkit. Basically, it's an library. It's used to build some programs to work on human language. So mainly, it will extensively, so that it extensively used in the Python programming. And second thing, it's very easy to use for the text pre-processing. So because in this we have multiple functions by default, this analytical library has builders, so those functions will be very helpful in the text pre-processing. And it also supports tokenization, parsing, classification, etc. We will discuss all those built-in functions what NLTK provides in the coming slides. Okay, so why should I choose NLTK? Okay, the NLTK, it's a great platform. It's open source library, so we can use and we can download, from the browser. And also because of this open source, you can it extensively worldwide. The uses of this NLTK widely used all over the world. And as I said before, it's a very rich tool for the text pre-processing because it gives many built-in functions for the text pre-processing. And third most important thing, it's very easy to integration with the Python. So when you have a machine, in your machine, if you have a Python programming, if you have NLTK, so both integrations very easy. It's not need much work for you. And because of this open source rich tool for the text processing, so most community using habited to use this NLTK. So worldwide a lot of community for this NLTK. So as I said before, NLTK has a pre-built-in functions so that we can do the text pre-processing. So these are the list in text pre-processing: tokenization, stop removal, stemming lemmatization, parts of speech tagging, named entity recognition, and ER, text classification, sentiment analysis. These are the predefined functions. So with all these, we can pre-process the data in many ways. Let me discuss about each and everything with how, what is the code behind it, how to code it, and what is. So when it comes to the tokenization, so usually in the tokenization we divide some big list of words, list of sentences, or the paragraphs into a tokens. The token can be a sentence, token can be a word, because if you have a paragraph, if you use tokenization dot sentences, it will convert the whole paragraph into the each sentences. If you have a sentence, it will convert that sentence, big sentence, into the tokens as a words, so that in tokenization you can convert sentence tokenization, word tokenization too. So to use this, if you see the Python programming I given in this slide is import NLTK, because to use this functions, you use the by default function, you use that NLTK library. From the NLTK dot tokenize, import word tokenize. As I said before, in the tokenize we have a different tokenizations like word tokenization, sentence tokenization. So from NLTK dot tokenize, import word tokenize, and NLTK dot puncate. So where now we giving as a sentence, NLTK is powerful library for analysis is a sentence. So we are stored in the text, and that we are dividing that sentence into the words by call the word tokenize of text. So if you see here, NLTK is it divides a whole sentence into each word. This is called tokenization. Next, stop word removal. Okay, so if you take the any what would I say, any paragraph, any sentence, in this we can find many things that are not relevant, apart from grammar, that are not won't affect the much understanding what it is about, what is the overview of the paragraph. So in this case, while we are processing the data, we are processing the input, and if we take the big data, it has a number of words, number of sentences, like millions of numbers, millions of sentences. In this case, better to delete the small words that won't affect them much to the main overview of the paragraph. So in this case, it will the pre-processing consumption time, it will be reduced. So for that case, we use the stop word removal. So in the stop word removal, what it will do is, as I said before, we already imported NLTK from import NLTK. Now NLTK.corpus, because the stop words are in the NLTK corpus. So NLTK.corpus import stop words, and you have to download the NLTK stop words, because all these list items the, and these are irrelevant except grammar. Only grammatically these are important in a paragraph. So for the machine, just to understand the what we are trying to say, that's it. So it will delete all those unnecessary little bit items that won't affect much. So by calling this, it stores the stop word stores into the stop words. So, and you can set the language too, because okay. And next, you can set the language so that it will remove the English words by calling the stop words. And next is stemming. In the stemming, we have in English we have a number of one word can have different meaning, like can have different forms. I can say, if you take as eat, ate, eaten, and eating, and will eat. These are all the one eat. I'm eating. I can eat, like this can we can all in a different forms for one word. So what it will do is, whatever you give, whatever form you give, whatever tense you give to the you have, it will convert into the normal way. Eating, it will convert to eat. Running, it will convert to the run. So for that we use this stemming, so it will normalize the words. So it will reduce the words to the root forms, what is the dictionary forms. For that we have a different in NLTK itself we have different things like port stemmer, snowball stemmer, and the lemmatizers. What is second? So here the three has three differences. Like if you take the port stemmer, it's a very speed, because it uses some very fast searching algorithm. It will remove the suffixes with ing, with end. Just it will give the root name. So by this, so it will be very fast in the pre-processing the data, but the accuracy will be less, because it if you can use it when you need accuracy, when you need speed time more. You can, if you are acceptable with a little bit inaccuracies. What about the snowball stemmer? So it's same as the port stemmer, but snowball stemmer is upgradation algorithm of the port stemmer. In the snowball stemmer, it's comparatively less than port stemmer, and its accuracy more because it's an upgraded library of upgraded algorithm of the port stemmer. So it gives more specified root word than the accuracy than the port stemmer. And this speed is also good than the port stemmer. And what about word lematizer? But still, in the snowball stemmer too, later very tiny accuracies will come. But in the word net lematizer, it uses a database which consists all the dictionary forms directly. So in this, the processing time will take more, but the accuracy will be very high because it will use directly the dictionary forms in a particular database. It will store in the database exact meanings. So whenever you give that kind of tense, whatever tense it will divide that each parts of speech into a normal into a root form. So the word lambda is the accuracy is more, the speed is less because it takes more time to do it everything. So I said before, parts of speech. So now we divide the word, we remove the stop words, we normalize the words. Now what? Now understand what is the word. He run, he run, road. Now this is the meaning. Now he is pronoun, run is verb, road is a noun, right? So this is misunderstand what he's trying to say now. We are now pre-process the data, now misunderstand. So to understand, we divide in English we divide parts of speech: noun, verb, adverb, adjective, preposition. So in this, the parts of speech will divide each word into that kind of thing. So now it will identify the what is the grammar of the category, what is the grammatical category. So if you consider this one, NLTK, from NLTK import POS tag, parts of speech tag we don't imported. Now we downloaded that, and parts of speech, now it will see NLTK is NNP, it's a noun, VBZ it's a verb, A is a DTT, DT is a determiner, and powerful JJ is a preposition, NN is the noun, IN is a preposition, JJ is adjective, sorry, and it's a noun. So these are the different parts of speeches. What about name entity? So as you know, now with parts of speech, now we got it. What it is parts of speech? Now we have to identify what is the general form. Is it a name? Is it a location? Is it a place? Is it a what kind of name entity it is? What kind of location it is? So for that we use the named entity recognition. For that you use from an entity dog chunk import need chunk, and you have to download the accent need chunker and the words, so that it will segregate which is the word. If you see here, organizational NLTK is a noun, is a verb. So by this it will give the proper identity, what is the location, what is the name, what tells each word. So this is conclusion of NLTK in the natural language processing. So from this, I got to know, like we all understood, like natural language kit toolkit is very powerful toolkit in the and for the NLP natural language processing, because it gives multiple tokenization, stemming, stop words, parts of speech recognition, named entity recognition. So it's very powerful tool for the natural language processing, and because it gives various functions, so it's very good for NLP tasks and for ideal research. So this is all about. Thank you for everyone. If you have any questions, just you can help me know. Thank you so much.